My dear students, and welcome to the session. Am I audible and visible? Okay, let me see. I'm just starting off my session. आज सुबह तो डर लग गया था कहीं इंटरनेट कनेक्शन ना उड़ गया हो, बट ठीक है फिर चल गया। हम्म आई बिलीव आज मुझे इसके अंदर सेकंड इंटरनेट कनेक्शन भी लगवाना पड़ेगा। Yes, I am audible and visible. So today we are going to start with the solid state. देखो सबसे important बात, the solid state chapter, as far as if you are CBSE student, this is not in the CBSE syllabus. The new NCERT does not have the solid state chapter. So now you can think it in two ways. One, you can think, okay, solid state chapter is not there in CBSE syllabus, so we are not going to do it. There's one way of thinking about it. And the other way is, oh, solid state chapter is not there in CBSE syllabus, so there won't be any NCERT and it will not be taught in school. So that is the second thing, that now we have to study it very nicely. So it is up to you how you are going to take it. I am going to teach you the solid state chapter thoroughly, completely, and hopefully we are going to finish off with the chapter today itself. Okay, so everybody, I believe everybody has got the information. So do I need to inform the people? Do I need to share the session? Share kar dete hain. Okay, so let's share the session today itself. Today's session. Yep, it is here. It's already started, and we have 12 people watching. So yesterday's session, we talked about the chemical kinetics. We had talked about the. ये क्या हो गया? Okay. Here we have. Here we have shared it on the Telegram channel, and here we have shared it on our group, the WhatsApp group. So now we are going to start over with the chapter solid state. This is the batch we are starting. जीते रहो बेटा अक्षय, सिलेबस पूरा करा दीजिएगा। ऋतिक प्रसाद, बेटा इससे तेज कैसे सिलेबस हो सकता है? आई थिंक वी आर गोइंग एट अ स्पीड जिससे ज्यादा हो नहीं सकता। एक एक दिन में एक एक चैप्टर खत्म हो रहा है, इतना तो क्रैश कोर्स में नहीं होता बेटा, एंड दैट टू थॉरोली। और क्या चाहते हो? लेट हो गया, कोई बात नहीं, होने तो थोड़ा सा लेट। Okay, now, so that is what we have as the code. Fine. So this is what we have as the dropper batch, the highlights. So we have Elixir dropper batch, and the batch timings are 6:30 to 7:30 p.m. Swati ma'am, 7:30 to 9 p.m. It's me, Anoop Vashishtha. 9 to 10 p.m. is Sachin sir. And this is Elixir dropper batch for NEET 2024 that has been started. Okay, clear? So this is what we have as coupons and offers. Use the code AV Live. You can use the code AV Live as well. Okay, here we have the code AV Live. You can use this or you can use WS Live, your wish. So we have Elixir dropper batch. You can use this particular phone number to join with us. Now that's me, Anoop Vashishtha, MSc in Chemistry. Yes, well, let's begin over the session. तो चलिए शुरू करते हैं with a session called the solid state. Now, आज हम ना mixture की बात करेंगे. We are going to have the slides also and we are going to have the written also. Now, these slides, I'll just upload it on the group. These things you do not need to write. If you want to write certain things, it's your wish. You can write it. I'm not going to stop you, but you don't need to necessarily write it. Is it clear? But whatever I write, you have to make your notes. Notes तुम्हें बनाने पड़ेंगे. अब देख लो तुम्हें क्या क्या नोट करना है. सारी की सारी चीजें नोट करने की जरूरत नहीं है. These are the informations. Now this chapter contains a lot of theory, okay, and a lot of explanations. Explanations you have to write. I'll do whatever I have to write. I'll do that. और आपको जो लिखना है आप लिखो. Now simple सी बात ये है कि this is an introduction. Clear? We have talked about on the gaseous state also, but now we are going to talk about this matter. Now, matter is made up of minute particles, and all matter particles have two fundamental properties. One, the matter particles have a net attractive force between them, and second, the particles are in a constant state of random motion. Clear? Now, these forces, they act opposite of each other. When the force act opposite of each other, under a given set of condition of temperature and pressure, which of these would be the most stable state? कौन सी state किसी atom की most stable होगी? That is the outcome of these opposing factors. The thermal motion tries to move the particles apart from each other, while the attractive forces, they try to keep the particles together and non-moving. Okay, the thermal motion tries to keep the particles random. Attractive forces keeps the particle ordered in a specific direction. Or you can say the attractive forces wants the system to have a definite shape and definite volume. The thermal motion wants to keep it in the gaseous phase. You need to remember the liquid state is more or less a transitory state. Clear? Liquid state does not exist for a long period. As you can very well see, if we talk about water, 0 degree Celsius is the freezing point of water and 100 degrees Celsius is the boiling point of water. And in between, this is a liquid. Below 0 degree, it's a solid. Below 100, above 100 degree, it is a gas. So for 100 degrees Celsius, it's a liquid. Considering the range of temperature that we have, 100 degrees Celsius is nothing. So liquid is somewhere in between where the attractive forces and the thermal motion are relative. So if you have to ask anything here, just ask it. Okay. So that's what we have as the attractive forces. Now, attractive forces are interparticle forces. Now, they may be interatomic. When we talk about the interatomic forces, this is what we have as the ionic bond. This is what we have as the covalent bond. This is what we have as the metallic bond. Okay. And when we talk about the intermolecular forces, now intermolecular forces are the hydrogen bond, the dispersion forces, okay, and maybe the dipole-dipole interaction. We are talking about the forces which can act between the gas molecules, because when we talk about a substance being a solid or a liquid or a gas, these are the forces which act. Here we are not going to talk about ion dipole interactions, because ions and dipoles do not exist in a pure substance. Ion and ion dipole interaction is there in a solution, and that too most often the liquid solutions. Is it okay? So we are not going to talk about the ion dipole interaction. So these are the forces: hydrogen bond, dispersion forces, and dipole-dipole interaction that we are talking about. Now, all forces in chemistry have electrostatic origin. Whether we talk about the dipole, whether we talk about the dispersion forces, whether we talk about anything, they are all electrostatic. That is, they are because of the charge separation. Now, more is the magnitude of the charge separation, more are the attractive forces. Clear? and stronger would be the force, and more are the chances that the substance is going to be a solid. Clear? Now, this magnitude depends on the charge separation, that is, magnitude of the charge separation and the distance between the particles. More you make the distance between the particle, less becomes the attractive force. Is this clear? Anyone has to ask anything here? You don't need to note it down, just study, understand. Clear? Now, the attractive force depends on the nature of particles. Now, we are going to talk about this in the solid state because we are talking about the kind of solids. So, when we talk about the kind of solids, we have to talk about the nature of the particles. Now, this would be determining the magnitude, how much charge is there on the particles, whether they are particles have the large size, whether they are having the dispersion forces, whether they are polar, whether they are non-polar, whether they are ions, and further, what is the distance between the particle. But distance between the particle is more like if we talk about the gaseous state. When we talk about the solid and the liquid state, the particles are as close as possible to each other. They are actually touching each other in the solid as well as liquid state. You need to remember, although NCERT says so, but solids and liquids do not have a density difference. The distance between the particle in the solid as well as liquid is the same. Fine? Clear? So the distance as it increases between the particles, and I told you in the gaseous state when we say that we have a low pressure, so low pressure the particles are far apart, and there the attractive forces becomes quite low. Vapors also exist because of the distance between the particles. In case of vapors, the attractive forces are actually greater than the thermal motion, but they still are in the gaseous phase because of the distance between the particles. If you increase the pressure and get the particles near to each other, then they are actually going to liquefy, and that is what we have as the vapors. Is it clear? So let's talk about the attractive forces. Clear? The attractive forces try to get the particles close to each other and hold them in the fixed position. That is, they try to reduce the volume and keep a fixed shape. That is, the attractive forces try to keep the fixed shape and volume. Okay? The attractive forces try to keep a fixed shape and volume. Now, there is something called the thermal motion. Now, thermal motion is the kinetic energy of the particles. And most important, the thermal motion depends only on temperature. If you increase the temperature of the substance, the thermal motion will keep on increasing. And if you keep the temperature same, whatever be the pressure, the thermal motion does not change. Thermal motion is the kinetic energy of the particles. This will not change with anything but the temperature. You keep the temperature same, this motion, this thermal energy, the kinetic energy remains the same. Now, this kinetic energy is working opposite to the attractive forces. The attractive forces try to keep the particles near to each other. This energy tries to keep the particles away from each other. It tries to keep the particles away, and it is trying to keep the particles random. I was searching for my glove so that I'll be able to write it a bit better. Okay, now you need to know one very important thing. Whenever we talk about the average kinetic energy, this average kinetic energy is always per particle. Okay, now the constituent particles, the energy is per particle. Yes, I am in my chemistry lab, no doubts to that. And today I'm going to show you the various structures as well. I have the structures with me. Clear? Okay, I'll just arrange my structures that I have with me. No problems. And today evening, I'm going to show you all the structures. I do have them with me. Today I have an incentive to create all my diagrams for the solid state. Okay, so equilibrium at 100 degrees Celsius will have the same average kinetic energy per particle. That's what you need to remember. Clear? So if the two substances have the same temperature, the thing they are going to have same is the average kinetic energy. Is it clear? Now, thermal energy, there are vibrational motion, that is rotational motion, that is translational motion. So we are not going to go much in detail. The thermal motion of the particle tries to push the particle away from each other and change the relative position of the particle. That is, thermal motion changes the volume and the shape of the substance. Is it clear? Now we come on to the definition of the solid state. So here we begin over with the solid state. A state, everybody who is there in the session has liked the session. Okay, I have also liked the session now. A state in which the attractive force between the constituent particle, that is atoms, molecules, and ions, completely overcome the thermal motion, so that the only motion allowed is the vibrational motion. Vibrational motion is across the mean position. Vibrational motion does not change the average distance. Vibrational motion does not change the relative position. Okay, so that is what we have as the thermal motion. Okay, that is what we have as the solid state. The average distance. And be very clear, I'm talking about the average. I'm not talking about the exact, because the particles, when they vibrate, the distance at an instant that keeps on changing. So the average distance changes. Clear? Average distance remains the same, but the exact distance at an instant will keep on changing. Average distance same, and the mean position, the relative position of the particles remains the same. Okay, so volume and shape are constant. So that is what we have as a definition of a solid. Okay. Another way to see to a solid is that solid is a state of matter that retains its shape and density when not confined. You can just keep a solid anywhere and it keeps on having the same shape and the arrangement and density. Density means the volume does not change with the same mass. Clear? Or you can say the substances which do not flow under the influence of their own weight. If you take a honey drop and you put it on the wall or side of a glass, then it will start moving down. So it will flow under its own weight. Okay? Is this clear? I hope this kind of an information gives you an idea about what the solid is. As you have very well seen that we are taking the classes, when we are talking about the classes, we are talking about their basis as well. Clear? The basis takes some time. but it ensures that you are able to understand the concept much better. Okay. Now, plastics are soft, but they are solid because they have rigidity and do not flow. Fine. Now, this definition also would include the sponge. Sponges, if you press them, they change the shape, but it is under external pressure, external force. So, sponge, although is soft and changes shape under stress, that is, if you apply an external force, it retains its shape under its own weight. It does not change its shape under its own weight. So, sponge is not a liquid, but it is a solid. Am I clear? Sir, this is a solid or this is not. And if we talk about the powdered substances, the powdered substances, they flow, but each particle, each visible particle has a definite shape and volume and density. So that is why the powdered substances are solids. They are not liquids. Because we are talking about each visible constituent particle. Each visible constituent particle has its definite shape, definite volume, definite density. Am I clear? And then there is a word fluid. Fluid is a word used for both gases and liquids. It is not used for solids. Solids are not fluids. Okay. Now you need to remember the solids and liquids. These are termed as condensed phases. Solids and liquids are termed as condensed phases. Clear? Liquids and gases are fluids. So you need to be clear with the words. Okay? The fluidity in the both of these states is due to the fact that the molecules are free to move about. So that's what we have as the liquids and gases. I hope I'm not going too fast, because whenever the slides are in front of me, then in that case I feel like, okay, you can read through and move further. Am I going very fast? Just tell me. In case of solids, the average distance between the constant particles is a constant, so the volume is a fixed one. Yes, future doctor. That also you need to ask me. I think that's very much visible to you. Okay, now, there is a word called space lattice. Okay, a space lattice. Now, what is a space lattice? It is a three-dimensional infinite array of points. Okay, lattice. Or lattice, simply I can say, is a three-dimensional regular arrangement. Okay. Now, this three-dimensional regular arrangement is written as infinite array of point which is surrounded in an identical way. Which is surrounded in an identical way by its neighbors. But that does not mean the neighbors have to be identical. Identical way. Clear? Let us say I have a black ball here. I have a black ball here. And this black ball is surrounded by a red ball here, which may be having the same size or a different size, and a white ball here, and a blue ball here. But blue won't be visible here because I have the color as blue, or let's say red ball here. No, red to ho gaya. Let us say a green ball here. Instead of a ball, it becomes a sign kind of hexagon or pentagon. And I keep on repeating this arrangement. So it is not important that the neighbors have to be same or identical. They can be different neighbors. They can be same neighbors. They can be different neighbors. And I keep on repeating this arrangement. Now that will be considered a regular arrangement and this will become a space lattice. Okay. It is not the particles are repeated. It is the arrangement is repeated. Is that clear? So that is what we have as the repeated regular arrangement. So whenever we have the regular arrangement in three-dimensional, that is a repeating arrangement in three dimensions, that is what we call as a space lattice. Fine. The constant particles in the solids have fixed position. They can only oscillate about their mean position. This explains the rigidity in the solid, and these properties depend on the nature of the constant particle and the binding force operating between them. So we are going to talk about both these things. We are going to talk about the classification of the solid on the basis of it. Okay. Now let's have the characteristic properties. We have already done these characteristic properties, but we are just going to write them as a kind of a summary. Now you can note down that summary if you wish to. Otherwise, you are going to get this page, this entire notes, you are going to get it uploaded. You are going to get it with you. Fine. Now let us see how you are going to make the notes of this particular chapter. I would really like to see that. The following are the characteristic properties. They have definite mass, volume, and shape. Now, definite mass, the mass is conserved. That is not a problem. Volume and shape. Definite volume, definite shape is the characteristic of the solid. Intermolecular distance are short, or you can say particles touch each other. Okay. The intermolecular forces are strong, which overcome the thermal motion. Okay. The constant particles, atom, molecules, ions have fixed position and can only oscillate about their mean position, that is vibrational motion. Okay. They are incompressible and rigid. Incompressible again means volume constant, and rigid means shape constant. And this would be under their own weight. If you really apply an extra pressure, then in that case, they will change the shape. And maybe in certain cases, even the volume. Is this clear? Fine. Good morning, Piyush. You are late. Anybody has to ask anything here? Well, it needs to be a two-way communication. Now we talk about the classification of the solids. And as such, there isn't any unique way of classifying the solids. So whatever purpose we have, we are going to classify the solids according to that. Now, first of all, we are going to talk about the classification according to the attractive forces. So here we have classification of solids. So the first classification of the solid is on the basis of the arrangement. Okay, so this is on the basis of arrangement. When I talk about the arrangement, we have the crystalline solids and amorphous solids. Now, when we talk about the crystalline solids, they have a space lattice. The crystalline solids have a space lattice. Whereas we talk about the amorphous solids, they have the arrangement of liquids. Okay, the amorphous solids have the arrangement of liquids, and that is why many a times they are called pseudo solids. That is, they are behaving like solids, although they have the arrangement of liquids. Quite obviously, they are solids. They don't, according to the definition which we have done of the solids, they are solids. They are not changing their shape under their own weight. So they are solids. But they are sometimes referred to as pseudo solids because arrangement wise, they are not of solids or crystalline solids. And they are also sometimes referred to as super cooled liquids. And these amorphous solids are also termed as glasses. Glass is a very peculiar, typical example of amorphous solid. So whenever somebody says quartz and then glass, whenever somebody says liquid glass, something like whenever we have the word glass, that is amorphous. Okay, so glasses, they are amorphous solids. Anyone confusion? So let's talk about the crystalline solids. What are they and what we talk about? The solids in which particles have three-dimensional regular arrangement, again, that is a lattice. Okay. In these solids, a small three-dimensional constituent means if we cut a part of the solid, a small part, and we keep on repeating it, then we can get the entire cells, or we do get the entire solid. Fine. And that small part, that which when repeated in three dimensions, is termed as a unit cell. तीर्थराज अभी तक लगाई नहीं है स्पेशल क्लास बट हाँ लगा दूंगा and there will be a special class of solid state. Is this clear? So in these solids, a small three-dimensional constituent unit can be defined, which gives the entire crystal by pure translational repetition. And the small three-dimensional unit, which can be defined, is called the unit cell. Clear? So this is what we have as the unit cell. So in the case of solid, if we get the arrangement in one part, that arrangement is repeated throughout. So by just looking at the arrangement of a small part, we can get the entire arrangement of the solid. So that is why we say that a crystal has a long range order. Clear? So that is what we have as the crystalline solid. Examples, we have sodium chloride. Now sodium chloride by instance is ionic crystal. And then we have quartz. Quartz is SiO2. Now this is a covalent network solid. Quartz is a covalent network solid. Now both are crystalline solids. Clear? Whoever has not liked the session, go ahead and like it. The characteristics of the crystalline solids, they have a sharp melting point. Okay, at a characteristic temperature, they melt abruptly and become liquid. And the simple reason of it is each particle has identical surroundings. Each particle is held by identical forces. So at a certain temperature, all these particles get the same energy and they separate out, or they get that particular bonds are broken. So that is why crystalline solids have sharp melting point. Why? each particle has same attractive forces holding, because each particle has the same neighbors. Same neighbors, same attractive force, same arrangement. So the same force is required to break them apart. I hope all your questions are being answered even before you ask them. So even before you could ask why the ionic solids, the crystalline solids have a definite melting point, I have given you the answer. Okay. Now, by the same reason, amorphous substance will not melt at a constant temperature. Amorphous substance will melt at a range, because there would be certain particles which are going to be surrounded more strongly, certain particles which have different neighbors, so different forces are going to be there. So each particle is going to separate at or break the bonds at a different temperature. So the amorphous solid, they mostly, when we increase the temperature, they first of all become softened, and then slowly and slowly their softness increases and then they melt. And that is typical of the glass. And this allows the glass to be molded in different shape, because in between this particular range where it is soft, it can be converted into different shapes. And that is the beauty of the glass. Fine. Clear? This disarrangement of the glass gives it its versatility. That is how glass can be used in so many places, and so many things can be made of glass. Okay? So this is what we have as amorphous solid. This is what we have as glass. The solids in which constituent particles do not have any fixed arrangement, they are termed as amorphous. Such substances may appear as solids by appearance. Substances by appearance are solids, but by arrangement of constituent particles resemble liquids. I have already told you this. Okay. They also are termed as supercooled liquids. Examples are glass, rubber, plastics. Okay. These are amorphous substances. And quite obviously, when we talk about plastics, each constituent particles of plastic is not identical. And that is why plastics turn out to be amorphous, because we don't have identical particles. How can we have identical arrangement? Clear? Those who have not liked the session, go ahead and like it. I know there are certain people who have not liked the session. Is this clear? Now, this is what we have is they soften, melt, and start flowing over a range of temperature. Now, this soft part is the one where we mold them. Plastics, they also can be molded. They can be melted. They can be turned around. So many things we do. We change their shape in this particular range. Clear? Conveniently regarded as extremely viscous liquids. So another name is extremely viscous liquid. Viscosity does not allow them to flow, and that is how they appear to be solids. Now, this is one thing very important, and this is a question which has been asked. They may become crystalline at some temperature. So there is a possibility that the amorphous solid may become crystalline. See, crystalline substances, they have low energy. So the amorphous substances thermodynamically have a tendency to become crystalline according to the enthalpy. So some glass objects from ancient civilization are found to become milky. Now milkiness is because of the crystallization in the glass. Okay? Amorphous solids have a tendency to flow, but that is wrong. This actually is wrong. I have written it because this is written in NCERT, so I can't refute it. NCRT has this particular statement. That is why I have written it. But actually, the amorphous solids do not flow. If they flow, they are liquids. People say that glass have a tendency to flow, but glass doesn't flow. It doesn't. Is it okay? Fine. So these are termed as pseudo solids or supercooled liquids. So I have got to the answer further. Now we have quartz that is crystalline and we have quartz glass which is amorphous. Okay. The only difference is the range of order. Quartz glass is amorphous, which has a short range order, and the quartz is having a long range order. It's crystalline. Now, this is what we have as quartz. As you can very well see that this quartz has an absolute regular arrangement. This section can be repeated, and we can keep on getting this section as long as we want. So we can just keep on repeating it and get the entire lattice, entire three-dimensional arrangement. So that is what we have as quartz, a crystalline solid. On the other hand, if we talk about the quartz glass, this is random and this is amorphous. There may be some short range order, but it resembles a liquid. Okay, so that is what we have as the quartz glass. And now let's talk about the isotropy and anisotropy. Okay. Now to talk about the isotropy and anisotropy, let me talk about a thing which you might know, which you might not know. Okay. And let's use the word which you might have heard of something like चक्रव्यूह. चक्रव्यूह. ठीक है ऋतिक, बिल्कुल सही कह रहे हो. क्वार्ट्ज क्रिस्टलाइन है और क्वार्ट्ज ग्लास अमॉर्फस है. How many of you have heard this word चक्रव्यूह? And it is used many a times in the language. If you know Hindi, I believe you would be knowing this word चक्रव्यूह. Anyone has any understanding? Any idea about what exactly is चक्रव्यूह? So Akshay, Ritik, Priyanshu, anybody who doesn't know about Chakravyuh? Sadhyantra. Sadhyantra, I'm not aware of. Ananya does not know what is Chakravyuh. Okay, fine. I'll tell you what the Chakravyuh is. Chakravyuh is a regular arrangement of army. It's a regular arrangement of army. Clear? It is like concentric circles. Okay. There are concentric circles. Now, each circle consists of the soldiers. Now, this is a regular arrangement, and the soldiers are standing in a regular pattern. There are columns. There are columns here. Okay. The columns of army. There are certain path to reach the center, and this center is the leader. Now, this leader is capable of organizing all the parts of the army from the center. He's able to see all the centers, he's able to relay its messages, and he's able to move the army as one unit. This army moves and it rotates. So, there are two motions of this particular chakra. It moves in a particular center direction and it rotates. And this destroys everything that comes in its path. So it is just going to rotate. The people are going to cut. If somebody is cut here, the another person from here is going to take the place and nobody can enter it. So this is the arrangement. A certain thing, a certain. Ritik, I'll just tell you what exactly it is. Okay, I'll just tell you what happened. Now, since it is a regular arrangement, it cannot be identical in every direction. There will be certain gaps in it, but those gaps are not visible from outside. An outsider will look at it as the same thing. Like an outsider will not be able to differentiate between a glass and a diamond. So if you are given a diamond and you are given the same cut glass, you won't be able to distinguish between them because they will appear to you the same because you are not trained for it. In the same manner, a normal person who has not been trained, for him this would look like a simple mass, a regular mass with no flaw, no breakings, no weak points. But a trained person will be able to check where the weak point of this arrangement is. And that weak point is called the dwar, the door of the Chakravyuh. And that door is specifically guarded by a strong warrior. Now, that warrior doesn't need to be at the door. So, it is not that you see the warrior and you know where the door is. The warrior is in such a place that he can guard that door. Now, this is the Chakravyuh Bhedan jise kehte hain. How to break this Chakravyuh is what is important information. The person who has created this view is able to break it. Is it clear? And since it is moving, the entry point keeps on changing. So you just can't say that, okay, this is the entry point, it is fixed. No, you have to identify the entry point and you have to identify the entry point of every concentric circle. It is not going to be in a straight path. The problem with this particular arrangement is it's a regular arrangement. So there is bound to be a weak point and obviously a strong point. If you get into this column, you are dead. Because this column is nothing but all the soldiers standing back to back. You won't be able to enter here. And how many layers you are able to make, that depends on the strength of your army. Dronacharya had made 7 layers of this. 7 concentric circles were there. And he was standing right in the center. And outside, at the first door, was Jayadratha. Jayadratha, who defeated all Pandavas except Arjun. Arjun was not there. Arjun knew how to go through the Chakravyuh. Is it clear? Now, what am I trying to tell you here? Why am I talking about Chakravyuh? I am not here to teach Mahabharata to you. Okay, and I myself have made the rule that no religion or politics or cricket will be discussed here, because here it is not religion, here it is not politics, here it is arrangement, a regular arrangement, and every regular arrangement is different according to the direction. As you can very well see, if I look the arrangement in this particular direction, it's going to be different. If I look at the arrangement in this direction, it's going to be different. I am going to get regular arrangement in every direction, but a different arrangement depending on the direction. Different strength, different properties, specifically the physical properties. And that is valid for every regular arrangement. And when I talk about every regular arrangement, I'm talking about crystals. Is this clear? So, when I talk about Chakravyuh, it is bound to have strong points, it is bound to have weak points, it is bound to have different strength in different direction. Clear? And this is what is termed as anisotropy. Anisotropy is difference in the various physical properties, not chemical, physical properties. Now, what are the physical properties? The strength, the shearing strain, how much force I need to apply to break it. Many a times it would have happened that a glass drops from your hand, it simply bounces off and you catch it. It doesn't break, but don't try it. And sometimes it so happens a glass is standing and you just flicks and it shatters. Although glass is not a crystalline substance, but it does have some properties of that. Or maybe a stone, maybe some crystal. At certain angle it shatters, at certain angle it doesn't happen. Nothing happens to it. So that is what we have as anisotropy. Another physical properties could be the magnetic properties, the electrical properties, something like graphite. Do you know graphite in a certain direction is a good conductor, and if you make it perpendicular to it, it becomes an insulator of electricity. Clear? Diamond doesn't have a single refractive index. It has a range of refractive index because its refractive index changes with the direction. And why does it change? Because the arrangement of particle changes. And this is what we know as anisotropy. Anisotropy is the characteristic property of crystals. Okay. And when we talk about amorphous substances is simply like a crowd, भीड़. जिस डायरेक्शन देखो एक सा ही दिख रहा है. डू यू नो व्हाई? जब अगर आपने कभी पुरानी फिल्में देखी होंगी, कुंभ का मेला, कुंभ के मेले में जिसको खोना खो जाएगा, बच्चे खो गए, मां बाप खो गए, बच्चे सब कुछ खो गया. Why did the people get lost in the Kumbh Mela? Reason? It is haphazard. It is random. All the people are moving in every direction. You look in any direction, you see the same arrangement. You are not able to distinguish which direction you are moving. You get lost. And that is isotropy. Same arrangement in every direction. Or you can simply say no direction has any arrangement, and that is why it has same arrangement. Clear? So random arrangement is something where is same arrangement in every direction, and that is for amorphous substances. So amorphous substances, they show isotropy. Anyone has to ask anything about it? So that is what we have as isotropy and anisotropy. If different physical properties such as electrical conductance, magnetism, refractive index have the same value irrespective of the direction in which they are measured. The substance is isotropic. It is the property of amorphous substance. Now, please understand, many a times we refer to iso with identical arrangement, but here it is aniso with the identical arrangement. Okay, crystalline. Crystalline substances are anisotropic. Amorphous substances are isotropic. Now, this is due to the random arrangement which translates into same arrangement of particles in the same direction, every direction. Fine? Clear? Now, isotropic and anisotropic is not such a very important topic. No, it is not a very important topic. The only thing is when you are reading through the chapter, you get confused. Iso and iso, iso and iso, what happens? Why is it regular? Why is it irregular? Why is it same in for the anisot or the substances which have no arrangement? Why it is different for the substances which have regular arrangement? So that's what we have as the isotropy and anisotropy. And if the different physical properties such as electrical conductance, magnetism, refractive index have different value depending on the direction of measurement, the substance is anisotropic. Okay. Now it is due to the difference in arrangement depending on the direction. It is a property of crystalline substances. Very clear, everybody? I hope it's not getting boring. It's interesting still. Now, since I had to write so much, that's why I made the slides. So amorphous solids are isotropic in nature. Their properties such as mechanical strength, refractive index, clear? The value of their physical properties is same in any direction. The crystalline solids are anisotropic in nature. Now here is a regular arrangement. As you can very well see that AB has a particular arrangement, CD has a different arrangement. Akshay Thakur says crystal clear. We are talking about crystals, so crystals have to be clear, isn't it? Okay, clear? Now there is one word called polycrystalline solids. Polycrystalline solids. Now, even I have been confused about the metals. Metals, they have the same property in every direction. Okay, they have the same electrical conductance wherever you measure it. They are malleable, they are ductile, you can beat them into sheets. What are metals? Should we consider them crystalline or should we consider them as amorphous? Now, they are in a peculiar property, and that is what we call as polycrystalline solids. The metals, they consist of small crystals arranged together, bound together. Okay, they have microcrystalline structures. Clear? So, individual crystals are randomly oriented. So, the metallic sample may appear to be isotropic even though a single crystal is anisotropic. And please be clear, we can have metal crystals. Like when we talk about the Davison and Germer experiment, it was done on a nickel crystal, not a nickel metal foil. Okay? Is that clear? So that is what a very important thing is there. And please remember, this was given in NCERT. This is given in NCERT. So it is going to be an important fact. It may be asked, which of these is polycrystalline? Which of these is crystalline? So they may be asking you this particular thing. Okay. And now, this already we have done. Now we are going to classify the substances on the basis of the attractive forces. Fine. Now, on the basis of attractive forces, the solids are classified in a different types. Many different types of the solids are classified. सोनू यादव कह रहा है सर इससे भी खराब पढ़ा सकते हो आप? नहीं बेटा, मेरे पास सिर्फ 26 साल का एक्सपीरियंस है खराब पढ़ाने का. अब 26 साल के एक्सपीरियंस के बाद मैं इतना ही खराब पढ़ा पाया हूं. ठीक है, हो सकता है जैसे जैसे एक्सपीरियंस बढ़ता जाएगा मैं और खराब पढ़ा लूंगा. अब क्या करूं, 26 साल में इतना ही सीखा है खराब पढ़ाना. वेलकम सोनू यादव एंड थैंक्स फॉर गिविंग मी अ व्यू एंड मे बी अ लाइक और अ डिसलाइक. बट लाइक और डिसलाइक कुछ ना कुछ कर देना, ठीक है? Okay, now. So here we have the classification of the crystalline solids. Now we are talking about the attractive forces. What exactly are the different attractive forces between the solids? Okay. Now there are different forces. There are different attractive forces between the particles. Now these are van der Waals forces. Now these are what we call as van der Waals forces are also of the three kinds. They are dispersion forces, dipole-dipole, and hydrogen bond. So these are van der Waals forces. Then we could have ionic bonds, then we can have covalent bonds, and then we can have metallic bonds. So these are the forces which are holding together the constituent particles of the solids. So on the basis of these, we have four categories. We have the molecular solids with the van der Waals forces. We have the ionic solids with the ionic bonds. We have the metallic solids with the metallic bond, and we have covalent solids in which we have the covalent bonds holding together the constituent particles. ठीक है? फाइन. क्या वो सोनू यादव कहां चले गए? गायब? यार, लोगों के पास कितना फालतू टाइम है ना, अपना टाइम वेस्ट करने के लिए आ जाते हैं अगर पढ़ना नहीं होता तो भी. Okay, so let's get along with the different types of the solids. Now, first of all, we talk about the ionic and the electrovalent solids. What are they and how do we find it out? These are formed by electrovalent or ionic bonds between the atoms of large electronegativity. Very, very simple example. Sodium chloride, cesium fluoride, potassium sulfate. Now, please remember, sulfate part is a covalent molecular ion, while potassium is a metallic atomic ion, cation and anion. But still, potassium sulfate is a crystalline solid and ionic solid at that. Fine. So they consist of oppositely charged ions. They are always solid at room temperature. Clear? They are always hard, they are always high melting, and they are always brittle. What does brittle mean? Brittle means if you strike with a hammer, then they shatter. They don't form a dent. Clear? Metals, if you hit, they are going to create a dent. I hope you know what is a dent. Okay. But when you strike an ionic solid, it shatters, it breaks apart. Okay. There is no dent which is formed. Clear? So that is what we call as brittle. Glass is brittle. Ionic solids are brittle. Now, when we talk about the ionic solids, they are non-conductors of electricity in the solid state, but they conduct electricity in the molten state or when they are dissolved in a polar solvent like water. Okay, so ionic solids do not conduct electricity in the solids. I would say pure ionic solids. How they can become a bit of conductor, that we are going to talk about in later in the defects. चूरा चूरा is different. थोड़ा सा I would say shatter. ठीक है, पूरा चूरा नहीं बन जाता, क्रिस्टल्स के टुकड़े हो जाते हैं, चूर चूर नहीं हो जाते. Okay. Okay. Clear? Sushmit, if you try to write these slides in your notes, you are going to actually print a book. These are not notes. This would be entire book. I would rather give you these notes. These will be present in your group. So the Telegram group that you have joined, you can get the notes from there. And you can get the notes from the WhatsApp group. Whatever group you have joined, you can get the notes from there. So this notes will be uploaded right now after the class. Clear? Now remember, the ionic solids are good conductors of heat in the solid state. Heat and electrical conductance are different. Do you know diamond is the best conductor of heat? And it's a good insulator of electricity. Whereas graphite is a good conductor of electricity, but it's an insulator of heat. So please don't confuse between the electrical and thermal conduction. Electrical and thermal conduction are two different things. Metals are specific where they are good conductors of heat as well as electricity. Is this clear? So in the case of ionic solids, obviously the ionic solids are ions are the constant particles. They are formed by three-dimensional arrangement of cations and ions bound by electrostatic forces. A proper charge separation is there. The magnitude of charge separation is high, and that is why the attractive forces are high. So magnitude of charge separation is high. Okay, that makes attractive force high. And that is why they are strong, they have a high melting point, they are hard. Clear? Now here they don't have free electrons. The ions are there and ions are bound. And that is why they do not conduct electricity. Molten state, and when dissolved in water, the ions are free to move and they conduct electricity. Is this clear? Then we talk about something like metallic bonds. Now they are formed between electropositive atoms, the metals. Now metallic bond could be weak, could be strong. Something like we talk about mercury. Mercury is a liquid. Melting point is equal to minus 38 degrees Celsius. That's for mercury. On the other hand, we have tungsten. Tungsten, the melting point is somewhat near about 3400 degrees Celsius. Tungsten has a symbol of W, Wolfram. And then somewhere in between, we have sodium, which is quite soft metal. Cesium, it's almost a liquid. Then we have gold, we have silver, we have iron, we have tungsten, titanium, we have so many ranges. So the metallic bond has a large range. All metals are good conductors of heat and electricity, including mercury, including lead. They have much higher electrical conductance than ionic conductors and obviously semiconductors, and very, very obviously the covalent substances. Okay, they all are good conductors. Okay. Now, when we talk about the metals, it's an orderly collection of positive ions surrounded and held together by a sea of free electrons. It is sometimes referred to as the electron sea model. Let's talk about what the electron sea model is. Electron sea model would be having a solid, this sphere, another sphere, another sphere, another sphere. ये छोटा क्यों करता जा रहा हूँ इसको बड़ा कर देता हूँ हाँ ठीक है साइज ठीक है okay another sphere. Now these spheres have a regular arrangement. They are arranged in a regular arrangement. Okay, and here we have the electrons. This is the sea of electrons. Okay, now these are the positive kernels. This is what we call as the metallic kernels. Okay, so this is a sea of electrons in which the metallic kernels are floating, and this is what we call as the electron sea model. This electron sea model is able to explain many of the properties of the metals, but it's not necessarily true. So it might be not a correct method, but it explains all the properties of metal. It explains the malleability, it explains the ductility, it explains the luster, it explains the metal's electrical conductance. So it explains all those things. So this is what we call as electron sea model. Fine. So metals are orderly collection of positive ions. That is what we call as metallic kernels. And they are held together by a sea of free electrons. These electrons are mobile and evenly spread throughout the crystals. Each metal atom contributes one or more electrons towards the sea of mobile electrons. And that is the conduction of the metal. Okay. When an electric field is applied, these electrons flow through the network of positive ions. Similarly, when heat is applied to one portion of the metal, thermal energy is uniformly spread throughout by free electrons. Actually, thermal energy is not spread by the free electrons. It is spread by the vibration of metallic kernels. And that is the reason why when we increase the temperature, the metallic conductance decreases. But NCERT says it's because of the free electrons, so we'll accept it as free electrons. Okay. Now, another important characteristic of metal is their luster. And sometimes in cases color, like gold and copper, They have colors. All other metals are more or less silvery white or maybe silvery dark like lead. And this also is due to the presence of free electrons which are capable of showing transition, absorption, and release of energy. Clear? And please remember, metallic luster is something which is characteristic of a metal. A metal is identified by its luster. Rest of the things may be shown by other things, but luster is the peculiar typical property of the metal. Okay. Now let's talk about the covalent network solid. Covalent network solid. And a typical example of covalent network solid is silica, quartz. Here we have in the covalent network solid, we have something like silicon. Here we have oxygen. Here we are going to have silicon. Here it's going to be oxygen. Here it's going to be silicon. Here it's going to be oxygen. Here it's going to be silicon. Here it's going to be oxygen. Here it is silicon. Here it is oxygen, silicon, oxygen, silicon, oxygen, silicon. And here we have again oxygen. Here again we have oxygen. Here again we have silicon. Simply oxygen, silicon, oxygen, silicon. So this is what we have as a three-dimensional regular arrangement using covalent bonds. Okay, this is what we have as covalent network solid. Is this clear? The covalent network solid. Fine. So this is what we have as covalent. Now please understand these are very hard, high melting, brittle. Okay. The examples are silica, that is quartz, diamond, even graphite. I don't know why the people confuse hard with slippery. I don't know. Graphite does not get compressed. It is not soft. It is not spongy. You cannot sleep on a graphite bed. Okay. If you hit somebody with a graphite rod, the head will break, not the graphite. But graphite is slippery because the layers of graphite slide over each other. So don't confuse slippery with soft. Okay. If you have the floor on which some oil is spilled, then in that case, if you slip on it, it is slippery. But when you fall on it, your bones will break because it's not soft. It is still hard. So don't confuse soft with slippery. Graphite is slippery but hard. Okay. And I don't know why they say graphite is an exception. Graphite has a regular arrangement, so it is a covalent solid. Covalent network solid. Covalent network solid has nothing to do with the electrical conductance. I don't know why they mix the electrical conductance with a covalent solid. There is no relation. Okay. So quartz, diamond, graphite, boron. Now, they would say that boron is also an exception because boron is a semiconductor. Even silicon. Silicon also is a covalent network solid and it's a semiconductor. Germanium, covalent network solid, semiconductor. Diamond, insulator, good conductor of heat. Quartz, again, it is having a kind of piezoelectric properties. So, there is no meaning of relating the covalent network with electrical conductance. Graphite is not used in pencil, beta. Tirthraj. Graphite powder with mixed with clay is used in pencil. Or rather, I don't know whether it's graphite powder or some other powders. And since they are all covalently bonded, you can even call them giant molecules. Each covalent network crystal is a single molecule. Is this clear? Any confusions? Okay. Now you need to understand that covalent bonds are strong and directional. Strong, I believe we understand what is strong, that you need to break those covalent bonds, you require energy. And when we talk about directional, the covalent bonds have an angle between them, a fixed, rigid angle between them. Clear? So a covalent bond is going to be formed in the direction of the orbitals. It is not randomly arranged. In case of ionic bond, we have a positive charge, we have a negative charge, and we can place the negative charge anywhere on the positive charge. We place the negative charges on the positive charge in such a manner that how many can we arrange? But in the case of covalent bond, that's what you can't do. Whether you have CI4 or we have CH4, the shape is going to be the same. So the size doesn't make a difference in the case of covalent bonds. If the size is too high, then the bond itself is not going to be formed. But you are not going to change the direction of the bond. No, beta Priyanshu Ghosh, the dry cell, the black rod we have is not graphite, it's a compressed carbon rod. Okay. I have the graphite crystal with me. In evening class, 4 p.m. class, we are going to have the practical views of solid state. Okay. Now, the solids are very hard and brittle. They have extremely high melting point and may even decompose before melting. They can decompose because the attractive forces are very strong. So, if you heat them thoroughly, then in that case, they decompose, they separate out. They are, that doesn't make a difference. Silicon carbide is an example, diamond is an example. Now, we have taken the example of those which are insulator of electricity. ऑर्गेनिक हम कब स्टार्ट होंगे जब फिजिकल खत्म हो जाएगी ठीक है it is not soft NCERT says I'll accept it now this part is written in NCERT and you have to remember it read through it anything you want to ask okay read through it oh are you able to see that this is the structure of diamond oh do I have the structure of diamond with me I'll have to just see. I have the structure of diamond with me. Well, I'll have to search for it. Where is my diamond? Not here. Okay. And that's graphite. Is it? I believe you can see it from the NCRT. NCRT, it's quite visible. Here it is purple colored and I have a blue background. Now we have the molecular solids. Here we have two kinds of forces. There are two different forces. Let's say we have solid CH4. Now, when we talk about CH bond, this is a covalent bond. But when we talk about the bond between methane and methane, now this is dispersion forces or London forces. Non-metals have free electrons. Graphite has free electrons, Piyush. Okay. Hello, Om Ragorte. How are you? Long time no see. Seeing you now. Welcome. Okay. Now, please remember when we talk about the molecular solids, when we talk about the molecular solids, the energy is required to break this bond. We do not break the molecule. The covalent bonds are not broken. Many times a question is asked, the covalent molecular substance have low melting and boiling point because, and the option is given as covalent bond is a weak bond. No, it is not a weak bond. The only thing is to melt the covalent molecular substances, you do not have to break covalent bonds. You just have to break intermolecular forces, which are weak van der Waals forces, dipole-dipole interaction, and at the max, hydrogen bonding. Is this clear? Is this clear? And that is why they have low melting and boiling point. When we talk about the low melting and boiling point, it is less than 500 degrees Celsius. That is considered the less melting and boiling point. Clear? Anybody who has not liked the session as yet, go ahead and like the session. And I believe, okay, we are going to finish off the molecular solids. Now here we have the crystals bound with hydrogen bonds are classified with van der Waals crystals. Okay. Hydrogen atom in the molecule permits hydrogen bond only in specific direction. The hydrogen bonded crystals have some features of covalent crystals. Like ice, when we talk about ice is hard, it is directional, it is crystalline. So although it is a hydrogen bonded crystal, it has the characteristic of the covalent network crystals. In doubts? Molecules are the constituent particles of the molecular solids. The molecules give us the the constituent particles. They only tell us. Fine. Now these are divided into four categories. That is atoms like argon and helium, or molecules formed by non-polar covalent bond like hydrogen, chlorine, and this. These are called non-polar molecular solid. These species which are attractive for the constituent particles, they do not have any dipole moment in them and they are not able to form hydrogen bonds. So these are non-polar molecular solids. The atoms of molecules are held by weak dispersion forces, which are London forces. They are soft, non-conductors of electricity. They have low melting points and are usually in liquid or gaseous state at room temperature, but not necessarily, usually. Yeah. Then we have polar molecular solids. Now these are polar molecules. HCl, SO2, and even NH3 has been mentioned as a polar molecular solid. Okay. Okay. Then we have polar molecular solids. We are talking about those only. Their melting point are obviously higher than those of non-polar because the attractive forces are stronger. We are rather than talking about the weak van der Waals forces, the dispersion forces, we are talking about the dipole-dipole interaction. Okay, so these are the solids. Then we have hydrogen bonded molecular solid. Quite obviously, the attractive forces are going to be even higher. So their melting and boiling points are going to be higher for the comparative, the non-polar solids or polar molecular solids. Clear? Like ice. Now that's what we have as the difference between the crystalline and amorphous solid. Just have a look at it. It's NCERT table. सर अगर कोई बच्चा पाकिस्तान से हो तो वो अनअकैडमी का सब्सक्रिप्शन लेना चाहे तो पेमेंट मेथड क्या है ऑनलाइन यू कैन पे इट I hope so. I believe so that you will be able to do it. You can make the payments. Credit card के through हो जाएगा. Whatever the interconversion of the currency is, it will take place. Anything you want to ask here? But whatever you talk, use the code AV Live. Now this is the classification of the various solids. Just have a read through it. Anything you want to ask? Any confusions in this particular table? Read through it. Anything you want to ask? Read through it. At this moment in this session, we are reading the NCERT also along with the session. So you just need to remember metals, ionic crystals, and van der Waals crystal. The forces and interactions that hold the particle do not act in any preferred direction. So these are non-directional bonds. In covalent and hydrogen bonded crystals, the bonds are formed only in special direction because of the directional characteristic of the covalent bond and hydrogen bond. Clear? Sea of delocalized electron. Sea of delocalized electron are electrons are able to free to move. Have you seen a sea, a river, a lake? The water can flow anywhere. And that's what we have as delocalized, not specified at one place. It can flow anywhere. And this is a sea of delocalized electron, the electrons which are free to move in any direction. पूनम सिंह सिंगल सर एक स्टूडेंट का 2022 में 41 मार्क था नीट में एंड 2023 में सिर्फ एनसीईआरटी सेल्फ स्टडी से दो। हाँ तो व्हाट्स द प्रॉब्लम इन इट पूनम? एनसीईआरटी और सेल्फ स्टडी, दैट इज अ डेडली कॉम्बिनेशन. Ananya Sarkar, 3 minutes break. Okay, have the 3 minutes break. Okay, you have 3 minutes break. That is, we are going to start at restart at 11:54. 3 minutes break. ले लो भाई. Graduation second sum. Hello, Ayushmani. I believe we have already had the 3 minutes break. Now we can begin over with the session. Okay. So let's talk about the study of arrangements. There comes to be presumptions. Presumptions mean that the necessary conditions or the conditions which we consider to be there. Okay, they might not be correct, but they ease the study. So presumptions are required to ease the study. Now, the crystalline solids are characterized by the arrangement of their particles. So, to classify the crystalline solid, we need to study the various possible. And it's not necessary that the possibilities may exist. The possibilities may be just maybe. Now, what are the presumptions which are used? First of all constituent particles, whether they be atoms, whether they be molecules, whether they be ions, they are considered non-compressible spheres. That is, they have fixed volume and they have the fixed shape. So that is what we have as non-compressible spheres. Clear? Then we have particles are placed as near as possible to each other, compact. And we are considering that they are touching each other. That is, whenever we talk about the arrangement, it is always closest, whatever the closest possible arrangement is. Please remember when we talk about touch, this is the distance of closest approach. I don't know when the two atoms touch each other what exactly touches. So is that clear? Any doubts? Now, when we talk about the crystal lattice, now it is the hard part. Something like let us say we try to make a almirah, and for that we have to take the nails, we have to take the hammer, we have to take the plyboard, we have to take the sun mica, we have to take the gum, we have to take the handles, and we have to arrange every constituent. So that's what we are doing now. If you miss any of these, the almirah would not be right. Is it clear? So these are the characteristic of the crystal lattice. We are trying to create the lattice. Now each point in the crystal is called the lattice point or the lattice site. Okay, each point. And each point in the crystal lattice represents one constituent particle. Now, this constituent particle may be an atom, molecule, or group of atoms, or an ion. So we are making a point, but this point actually resembles the entire atom, molecule, or ion. And we are representing it as a point. Fine. Now, these lattice points can be joined by straight lines to bring out the geometry of the lattice. So what the geometry of the lattice is, it is brought about by joining the lattice points or these points in a crystal lattice which represent one constituent particle. Clear? Anybody who has not liked the session, go ahead and like it. Is this clear? Now further, the simplest unit representing the entire structure is called the repeating unit. What needs to be repeated? We are going to repeat this unit and we are going to get the entire structure. When we talk about the complete structure, we simply repeat the units. It's like, what is a wall? It's a repeating bricks. Fine. What is the floor? It is repeating tiles. What is the house? Repeating rooms. So something like that. We have a repeating unit. We have a two-dimensional repeating unit. We have a one-dimensional repeating unit. We have a three-dimensional repeating unit. So there are two requirements for the repeating units. First, it should give the entire arrangement by pure translation. That is, if we have this as the repeating unit, I can take it this way. I can take it this way. I can take it this way, this way, this way. I can take it in any direction, but I cannot rotate it. No, this is not allowed. So it is pure translations. No rotations allowed. It is something like you are creating a design on a on some cloth, and you have to put that stamp. You lift it up, you put it here. You lift it up, you put it here. You lift it up, you put it here. You lift it up, put here, 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 here. You can go like this. 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 You can go like this, but you cannot rotate it. Is that clear? So that is one condition that we need. And further, the next condition is there must not be any empty space in the arrangement of the repeating unit. There should not be any gap. They should join with each other. No gaps are allowed. So these are the two conditions that any repeating unit must satisfy. Any kind of confusions here? No doubts? Now there we have lattice parameters. What is a lattice parameter? See, when we talk about the repeating unit is going to have certain dimensions, certain way to create it by information. Maybe in the lower classes in mathematics, you might have created triangles by knowing some values. That is, you may be given two sides and one angle, and then you need to create the triangle. Or maybe you needed to create a quadrilateral. So you were given certain values. Using that, you were able to create that particular figure. Okay. Okay. Fine. So to create a structure, you need certain quantities, certain measurement. That could be angle, that could be sides. Fine. Now, the minimum quantities that you require to prepare that repeating unit is what we call as the lattice parameter. Am I clear about the definition of lattice parameter? Okay. The minimum number of quantities that must be known to perfectly form a lattice arrangement, or rather, I should say, it is the repeating unit. That will be termed as the lattice parameter. Now, obviously, these are the set of lengths and angles because we are not talking about the spheres. Okay, remember, a sphere cannot be a repeating unit. Reason? Sphere, when it is arranged, it cannot be occupying the entire region. It will always leave gaps. The sphere is not a repeating unit. Fine? भाई like कर देना जिसने like नहीं किया. I hope nobody is having a problem with my English now. My English is very much understandable. I hope you have already forgotten that this is a pure English channel. And when I am telling you, then you are getting reminded. Fine. So let us see, for making the different kind of repeating units, how many lattice parameters do we require? कभी कभी हिंदी में भी समझा देंगे बेटा, अगर कहीं कोई बहुत ज्यादा कंफ्यूजन होगा, बहुत ही ट्विस्टेड टॉपिक होगा, तो ठीक है, हिंदी में समझा देंगे, उसमें क्या दिक्कत है? ये कोई बात थोड़ी ना कि ना हम तो जिद पर रह नहीं करेंगे, जिद नहीं है. इट इज ओनली लाइक इट्स बेटर. So why CAM PDF is not available in the NEET Elixir channel, Shubham Kumar? Because it is available in the WhatsApp group. So join the WhatsApp group, Shubham Kumar, and then you are going to get all the NEET Elixir. Okay? And CAM PDF is available on my group, and the notes are being created by students. So you will also have to create the notes. These notes will be provided to you in the channel because these are printed notes. Handwritten notes are not provided because those notes you are supposed to note. Is that clear? Anybody who has not liked the session, go ahead and like it. We have got only 30 likes. Link for what? Could anybody give the link to Shubham Kumar? You can give my phone number to him. Okay, let's get along with it. Now here we have something called the coordination number. Again, we are talking about the different definitions. What is the coordination number? Coordination number is the number of nearest particles. Now that is what we call as nearest neighbors. Okay. So what is the coordination number? Coordination number is the number of particles touching a given particle, equidistant from a given particle. Clear? Now they may be same type or different. They are at a fixed minimum distance and they all are equidistant. Yes, they can be same or different, Rena. Fine. So that is what we have as equidistant. Fine. And then we have something called a void. What is a void? Void is the empty space in any arrangement, any empty space which is not occupied. Clear? Now, you need to understand that the atoms now are not going to fit with each other thoroughly. Most of the atoms and molecules are spheres or maybe even cylinders or whatever they might be. They are not going to fit without leaving any gaps. So whatever the way the atoms, molecules or ions are packed, there will always be some free space, and that free space is called void. Am I clear with this definition? What is a void? Now, as you can very well see, people say that, sir, detail में पढ़ाओ. बेटा इससे ज्यादा पूछ क्या खींचनी है? इससे ज्यादा पूछ तो खींच नहीं सकते. Okay. Now we have something called contribution. We are just talking about the definition. We are talking about the definition of the various terms that we are going to use in this chapter. What is contribution? Contribution is that whenever we talk about the repeating unit, now it is not necessary that the repeating unit is going to include the entire constituent particle. See, what happens is, let us say we have two rooms. One room is this and another room is this. Now, this is the wall between the two rooms. Now, this wall, if somebody asks you, this wall is a part of which room? The answer is the wall is the part of both rooms. The question is, who owns the wall? The answer is that each room is going to own equal part of the wall. So this particular room owns half of the wall and this particular room owns half of the wall. So the two rooms own half of the wall each. So the contribution of the wall to each room is 1 by 2. Ha Ritik, near about 1 o'clock. Is this clear? Is it clear? बेटा अब लेंदी सेशंस की अगर आदत हो गई है तो दैट इज गोइंग टू बेनिफिट यू इमेंसली इन द फ्यूचर. एक बहुत इंपॉर्टेंट बात यह है कि आपकी जो सीटिंग कैपेसिटी है, जो बैठने की कैपेसिटी है, दैट हैज इंक्रीज एक्सपोनेंशियली. कहां आप आधा घंटा ठीक से नहीं बैठ पाते थे, अब आप 3 घंटे आराम से बैठ जाते हो. आई टेक द क्रेडिट फॉर दैट. ओके, क्लियर? टेल योर फ्रेंड्स ऑल्सो टू अटेंड दीज सेशंस because that's going to benefit them also, and somehow मुझे यहाँ पे क्लास में कुछ बच्चे दिखाई देंगे. Okay. So when we say that it's not necessary that the repeating unit would include the entire constituent particle, most of the times only a part of the constituent particle is associated with a particular repeating unit. Okay. While being the part of other repeating unit as well. Fine. Now the part which is associated with a repeating unit is termed as a contribution of the particle. I hope you are clear with what is contribution. Fine. Okay. So that is what we have as the contribution. Okay. Now we can have the contribution of the various particles. Uh, Let me create an arrangement. Let me create an arrangement. Okay. Now this is a cube. One cube. Clear? And this is another cube. What I do is I attach it here. Okay. Here I have attached the cube. Fine. And then I have another cube. I attach it here. Here it is attached. I have another cube. I attach it here. And another cube. I attach it here. Or rather, I should put it like here. Here in front of it. Another cube. It is here. Another cube. It is here. And another cube. Which is here. Okay. Now let us say we have a particle at this point. Can you count how many cubes are sharing this particle? Is this clear? Now, this particular center is being shared by 8 cubes. So its contribution to each cube is going to be 1 by 8. अनन्या दिख तो गया, अब येलो क्यूब सो तो गई. Fine. So it is being shared by 8 cubes. So the contribution of a particle at a corner of cube is 1 by 8 to each cube. Any confusions? Is that clear? So this is what we have as the cube. Now, so if we talk about this, only 1/8 of an atom or the molecule or ion actually belongs to a particular unit cell at the corner. Fine? Any doubts? Any confusions? Now, if I place an atom right in the center of the body, that will be the completely the part of the body. So that will be having a contribution of 1 unit. Is it clear? It's something like you put a fan in the room. If you put the fan in the room, it is not going to give the air to the adjacent room because it belongs to the same room. Okay, this will be having 100% contribution. Okay, this will give 100% contribution. Any problems with that? Very clear? If atom is located at the face center, that is at the wall, that is, let's say we are create a window. That window is going to be of the 2 rooms, like a wall. So wall is a contribution of 2 rooms. So this is going to be having half contribution to each unit cell. Any doubts with that? Any confusions? So the face centers have a contribution of 1 by 2. Okay. Then there is another word called packing efficiency. Okay. We very well know that any kind of arrangement is going to have voids and there is going to be the particles. The particles are not going to occupy the entire volume of the solid. There will be some vacancies. So the volume actually occupied by the particle divided by the total volume of the solid gives us a fraction of the volume actually occupied. You can say it fraction, you can say it percentage. Now, this particular fraction of the total volume actually occupied is what we call as packing efficiency. And very obviously, the packing efficiency cannot be 1. Clear? The packing efficiency cannot be 1. ग्रेट अनन्या, इसी स्पीड से पढ़ाएंगे, कोई जल्दी नहीं है. Fine. So this is the packing efficiency. It is represented most often like eta. Eta is equal to volume occupied by particles divided by volume of the solid. That is what we have as packing efficiency. We can even say volume occupied by the particles in a repeating unit divided by the total volume of the repeating unit. So it could be as a repeating unit also, because this efficiency is an intrinsic quantity. Whatever is the efficiency of a unit, that will be the efficiency of the entire solid as well. Okay, so eta is equal to, I rather would say, volume occupied by particles in repeating unit divided by the volume or maybe area of repeating unit. Okay, it could be also area. Area is for 2 dimensions, volume is for 3 dimensions. Is this clear? Okay. So this is what we have as the packing efficiency. Some people call it packing fraction, but packing fraction is more like for the nuclear structures. Nuclear chemistry, we talk about packing fraction. Fine. So that is what we have as packing efficiency. Read through it. Any kind of confusion in this part? Prerna Rajput, हम sums करेंगे in tomorrow's class. Tomorrow we are going to have a class of chemical kinetics and we are going to have a class of solid state. Fine. So tomorrow we are going to have two classes for that. Okay. Just read it. So today's class we are ending at this point. This session we are ending at this point, and we are going to talk about the session in the evening. And hopefully today we'll be able to finish off this chapter. So this is our biggest offers, 25% off on all plus and store subscription. That's what is happening. Iconic mega sale is going on. And this is what we have as the schedule. 2 p.m. you are going to have a botany class today. 3 p.m. no, today Saturday. Sachin sir is not taking any class. And 4 p.m. again you have a chemistry class today. Okay. So join our Telegram channel for YouTube classes, PDFs, t.me/NEET Elixir. You are going to get the session, this notes after the evening class. And tell your friends about these classes. We are having 13 students at the moment, 13 to 12 students. We should have at least a little bit more. Okay. Fine. Join with me. And this is my schedule. This is my page on Unacademy. Join with that even. Subscribe to NEET Elixir by Unacademy for the best live classes. Thank you. Bye-bye. Good afternoon. We are going to meet at 4 p.m. once again. Bye-bye.